So today we're going to talk about adding and subtracting like fractions, or fractions that have common denominators. So because they already have common denominators, it's really just going to be an addition or a subtraction problem. You're going to find, however, that integer rules are going to come into play for this. So when you see fractions and you're asked to either add or subtract them, you need to ask yourself, do I have common denominators? Today the answer will be yes. Tomorrow you're going to have to convert them. Then all you're going to do is combine the numerators. And I say combine because it's a little more generic. It works for addition and subtraction. And you know, when we throw integers in there, sometimes you're adding, but you really subtract. Sometimes you're subtracting, but you're really adding. All of those integer rules still apply. So I have 3 examples for you that are strictly addition, and then 3 examples for you that are strictly subtraction. Our first one, 5/9 plus 2/9. You're going to see a lot of times where they will combine the problem over a single denominator because they're the same. You have 5 pieces on this one and 2 pieces on this one. They happen to be the same size, so we just put them together, and this gives us a quick 7/9. Those were both positive, easy cheesy. Now, these happen to both be negative, and if you remember your integer rules, when the signs are the same, we just add them. So this would be like having 3 reds and 1 red, or 3/5 of a red and 1/5 of a red. So it's like saying -3 plus -1 all over 5. You know that -3 plus -1 is -4. So my answer is -4/5. Remember also that negative could go up top, it could go in the middle, or it could go on the bottom. If you're putting it in the middle, and I'll show you on this one, be sure that you're leaving space so that it is clearly a negative sign and doesn't look like it blends in with the fraction bar. So again, for number 3, we have common denominators. This would be a -3 plus +1. They are different signs, so I have to subtract. 3 minus 1 is 2. 3 pile is bigger, so we'll keep that sign, and then the 7. I usually put my sign up at the top just because there's no way that it's going to get confused with the fraction bar, but you can put it in any of the 3 places. All right, let's look to our next one. So we have common denominators. This one is subtraction. This is a case where I think writing it as one big fraction on top actually makes a little bit more sense. A lot of times as we get into these problems, students will say, well, is that a subtraction sign or a negative sign? And me having a little bit of a smart aleck streak says, yeah, it's both. And then they look at me highly confused. So the way that it is read is -5 minus 3, we put it this way. But you know that I can do the 2-stroke, and then it becomes -3, -5 plus -3. As we move forward and you get more and more practice, you're going to learn and train yourself to just kind of stick it to the other number so that this is really a -5 and this is really a -3, and then we combine them. That's a little trick you'll start to see as we do more. In any case, I've done my 2-stroke, I've turned it to addition, and my signs are the same. When I have the same sign, I add. So this becomes -8 over 8. Please don't leave it like that. You know that can be simplified. If I didn't have the negative sign, 8 over 8 would be +1. So because I have the negative sign, my answer is -1. All right, let's look to number 5. This problem is 5 minus 7. I'm taking away more than I have, so I'll do a 2-stroke. It becomes 5 plus -7. Since they're different, I'll subtract. Keep the sign of the bigger pile, and don't forget your denominator. -2/9. The last example has just about every negative sign and subtraction sign and everything you could ever imagine. So I'm going to rewrite this as one big fraction, and I'm going to eliminate the parentheses because that's just more I have to process. So this is -11 minus -5. I don't like subtraction, so I'll do 2-stroke. And it's now turned my problem to -11 plus 5. I'm adding. I have different signs, so I really end up subtracting. 11 minus 5 is 6. The bigger pile was negative, and then I have a denominator. Again, please don't leave it like that. You know that can be simplified, and we always want our fractions to be as easy to work with as we can. So 6/12 is really 1/2 with a negative sign.